This video is going to be all about the WDT, sometimes called the Weiss distribution tool or wire distribution tool. I usually just refer to it as a whisk because that's kind of what it is. And so, you hear a lot about these things, and I really wanted to know, what does it really matter? What does it really affect when it comes to espresso extraction and flow rates? And so I've conducted a gigantic test where I have pulled 90 different shots with various methods so that I can figure out, what does this little tool actually do? So if you'll stick around, I will show you all the data that I have collected and my conclusions based on a fairly structured statistical analysis of that data. So first up, let me talk you through the methodology of this study because I tried to be very, very careful. So first thing to consider is what type of coffee I'm using. This is the Magnum Exotics Blue Mountain Blend. It's available at Costco. It's fairly inexpensive, and it's kind of a medium roast coffee. This is my daily driver. Not that anybody watched the video I put out about coffee, but this is what I typically use. It required a lot of coffee for this test. Again, 90 shots. I stuck with a pretty standard 18-gram dose, and I used over 3 pounds of coffee doing this test over the past week. So each shot was measured by hand, and so I would dose out, and I actually made sure that I ended up with 18 grams of ground coffee. So I did weigh the doses going in, but I actually overdosed a little bit so that I would make sure that I would get 18 grams out. I thought about using the automated system that I'd made for my grinder in an earlier video, but I found that it just wasn't consistent enough for what I wanted. And I was able to actually keep each dose at exactly 18 grams to within 1/10 of a gram, because that's the limit of my scale's ability to read. Each dose was then placed into a bottomless portafilter with an IMS basket. And then we got into some differences depending on which method I was going to use, but all shots were then leveled and tamped with this Normcore dual-sided tamper. It's springed, so that means that it bottoms out on the top of the basket, and so it makes for a very consistent tamping experience. I then also used a puck screen on top of every shot because that is what I normally do in my daily routine. I then dialed in the shots at the beginning of this process so that I got basically a 40-gram output of total espresso in around 30 seconds. Now, this ended up causing some issues that I'll talk about later, but I didn't change anything throughout this process. I did not change my grinder. I did not adjust the machine. I let everything just kind of be random after that based on how everything ran. The machine was set to 95 degrees Celsius, and again, I let the machine govern its own temperature so that everything was out of my control. In between every shot, I cleaned and rinsed the cup and made sure that it was dry so that I would not carry over any water from the previous shot. It's also worth mentioning that I used bottled distilled water throughout the entire test. So no tap water contamination. It was all store-bought distilled water, just to keep the results as consistent as possible so that I knew I was using the exact same water for every shot in this test. I also cleaned and rinsed the portafilter and basket and made sure that everything was dry before each run. Also, before each session of testing, I actually ran an initial shot that was unrecorded. That way, the machine was kind of in a stable state before I started doing any data collection. As you can see, I also monitored the temperature and humidity of every shot throughout this test. There wasn't a ton of variation, but I did notice throughout each session the ambient temperature did go up as the espresso machine kind of heated the area around it. And I'll talk more about that whenever I discuss the statistical results of this test. I also decided not to use the volumetric dosing of my machine because, again, I found that it was not precise enough. As I was aiming for a 40-gram final mass in the cup, I made sure that every shot was between 38 or 42 grams. Those were the upper and lower bounds. If any shot went more or less than that, I redid them. And that gave me some reliable control on the output mass, which is part of the calculation for extraction. Now, since I was manually controlling the final output, there was some variation there, but everything was recorded and documented. And so I tried to be pretty precise. And the last thing to note is I am using my data collection scale for this process, so I was also able to capture the mass all the way through each shot. So I'm able to look at flow rate profiles and things like that. Again, I collected a ton of data throughout this process. So I have shot traces basically for almost every shot out of all 90 samples. I did lose a few when the app crashed. I may reprogram it later if I ever choose to do something like this again, which I doubt I will, because this was a hell of a lot of work, and I don't know that it's actually going to end up being that interesting for many people. So after every shot was pulled, I quickly would come over and I would test for the total dissolved solids within that shot using this refractometer. Now this is the DI fluid, the digitized fluid extract 2. So before every session, I would calibrate this unit with the same distilled water that I was using for my test. And in between every shot, it was rinsed and cleaned and dried so that it was in a constant state for every test. In addition, more than just total dissolved solids, this unit also gives you the temperature of the fluid at the reading. And so I also collected that temperature at the time I measured the total dissolved solids in each sample. If I ever encountered any problems with a test, because sometimes the unit wouldn't read for a long time, I would rerun it. I only actually threw out one data point and reran that test. So I actually took the first reading that the refractometer gave me for all but exactly one shot, and that was because that shot threw out like a 20% total dissolved solids, which is ridiculous. That would mean like 40% of your puck is gone. And so when I redid it, it gave me a much more reasonable value, and so I kept that one. It is noted in my data set. It doesn't really affect anything. It's also worth noting that the output that you get from this refractometer is actually an average of 3 tests. So I actually, am recording the average value, not an individual single test value. That is how this refractometer is defaulted to. It does take the average of 3 samples for every sample fluid, for every measurement that it gives you. So now we're going to talk about the main variables of interest. How did I actually do the WDT? So I tried to follow kind of best practices based on what I've seen in online videos. Basically, if you watch the Lance Hendricks video where he talks about WDT, I am doing what's known as like a deep WDT method, where I put on a portafilter funnel to keep everything in the portafilter basket, and then I do deep WDT method. So I'm going all along the bottom, making sure to catch all the sides and do as much as I can, and then I'm slowly, in kind of a spiraling fashion, going around and around up through the puck, and then leaving a nice kind of brushed finish on top. I would then tap lightly to kind of settle the coffee, and that was to make sure that the tamper got all of the coffee into the puck. I would then level the coffee using the leveler side of the norm core, and then I would do a solid tamp. And again, this is a spring-loaded tamper, and so it does give you fairly constant pressure if you're using a constant dose, which I was. So the tamping pressure should have been very consistent throughout this test. I do have it set to around 30 pounds based on my testing, but again, whatever variation is there is random and out of my control. The main test was WDT, but there's a different method that I wanted to check because this will kind of help isolate whether it is the distribution effect of WDT or the clumping effect of WDT that actually drives any results that I might find, and that is doing WDT in the cup, in the dosing cup. And so for this method, I would basically do the WDT method, but I wouldn't do it in the basket, I would do it in the dosing cup. That means you would not get the WDT distribution through this, but you would get the clump busting. And so this would kind of isolate those two different effects that WDT has so that I can see, hey, is any effect driven mostly by the distribution, or is it simply the breaking up of clumps that really drives the main benefit? And this did produce some rather interesting results. Now, the other method was just do nothing. Just dump the coffee in, tamp it, and go. And so I ran 30 shots with each method. And for each shot, I would, again, target a 40-gram output dose, considering only outcomes between 38 and 42 grams as valid. And I would record the output of every shot, as you can see here, into the app that I built on my phone using this Bluetooth connected scale. This allows me to output all this data into Excel or any other data program for analysis. And so I ended up with a lot of data, right? Because again, I'm recording mass at quarter-second intervals for all 90 shots. Now, I did lose about 10 or 12 shots due to data loss when the app crashed. I did do this test over multiple sessions, so let me show you some of the other data that I collected just so you can understand the amount of control variables that I'm able to use in this test. So here's the basic data, and you can see that I've got my method recorded for each shot. I've got some test shots here, and this is where you can see my final test ran for about 36 seconds. I had 41 grams out, and that was about the range that I wanted to be. The previous one, I didn't get the clock time, but it was close to 30. What I actually did to make sure that I kept track of the time well is I actually videoed every shot so that if I lost track of the timer, I would have a video that I could go look at to double check to verify. You can see I recorded the input mass, but since I measured that and adjusted it by hand, it was exactly 18.0 grams for every single shot. The other thing that I want to start off saying is that because I was concerned about the bias of the order of testing, and this is anytime you're doing an experiment, there are potentials for biases because I wasn't doing blind testing. I knew what I was testing. In the order you do things may change the outcome because, you know, the espresso machine warms up, the grinder warms up, different ambient conditions can change that may be correlated with the sequence of your testing. So I randomized the tests, and the way I did that is in Excel, you can actually generate random numbers. So first up, I made a list, like I would just say, okay, the first 30 shots will have nothing. And so I just made a list of 30 entries that would just say, you know, none. And I would pull those down. Then I would say, okay, I'm going to do another 30 that are WDT, and I would make those, and I would pull another 30, and then I would do the same thing for dosing cup. The next thing I did was I used a random function, and you can see it says returns a random number between 0 and 1, and that just gives a random number to each of these. Then you paste values, that way it doesn't overwrite, and then you can sort on this randomized number, and it gives you a randomized list of the testing conditions that you care about. And so that's how I created the random assignment of tests for each observation. I also recorded which bag of coffee each shot came out of because I did have to open a second bag throughout testing. I recorded the date so I could also capture how old the coffee was for each shot. I recorded which session, just in case there was something weird that correlated with the session. Sometimes I did more than one session on a day, but again, I wanted to record that series. This also allows me to capture the shot order. So I did most of these tests in runs of 10, and so this also lets me capture which shot was the first out of 10 and which one was the last out of 10, because again, during each session, things might change, things might heat up, conditions might be volatile throughout that session, and so I can calculate which shot was first and which was last in any session using this number. I recorded the temperature and humidity, although the humidity did not provide very much variation. What I did notice is that the temperature on the counter did rise throughout most of the data series. And I kind of attribute this to the thermometer being located close to the espresso machine, and so it probably heated the ambient area around the machine as I used it for more and more shots. And, as steam's coming off the puck, it just kind of heats up the area. It wasn't dramatic, usually not more than a couple degrees, but it's something I can control for in my testing. For the clock time, this is the time from the machine. It should be noted that I am using pre-infusion of 5 seconds, so the actual pressurized time is 5 seconds less. And I started off shooting for 30 seconds. My first run was 32, but what I found was overall I was pulling very quick shots. Again, I didn't want to change anything during the test, but the shots did start going quite quickly after the first day. And toward the end, they started going fairly quickly. And my overall average shot time throughout this process ended up being about 26.5 seconds. However, there was one major issue during the test that happened that I really still can't explain. And that occurred during the last day of testing. Now, I ran a bunch of shots through this machine. Nothing seemed to change throughout that whole time. But then on the 76th shot, you'll see that it took a whole minute to get 39 grams out. And after this, everything ran slower. So prior to the 76th shot, the average time of my shots for this test was actually 24.3 seconds. Now, granted, that includes 5 seconds of pre-infusion. So I was running like 19, 20-second shots, more like a turbo shot, really. For the last several shots, the average was like 37, 38 seconds, including this one that was 60. So something happened to make the extraction go a lot slower during this time. All I can imagine is something in the grinder may have shifted, but I did not want to adjust anything myself. So what I did is I actually can include a variable past this point, and I just call this an event. And after this event, everything runs much slower, but it shouldn't really be correlated with anything else in the test, and so I can account for any bias in the results by just using a dummy variable to capture, hey, all of these shots are post that event time. The next thing I captured was the presence of channeling. Now, this is very subjective, so I would say don't put a ton of faith into the results on channeling, because this was just me watching, and I had a pretty high standard for channeling. I just recorded yes if I saw a coffee squirt or spurt out of the puck. Because I was using a bottomless portafilter, I was able to watch that, and so it is subjective. So I would not consider those results very rigorous. I documented the output mass to the 10th of a gram. Again, I only kept results that were between 38 and 42 grams, keeping it, again, basically plus or minus 5% on my average shot. My average shot for this test did end up being about 40.5 grams, so I did a fairly decent job, even though I was doing this by hand, at controlling the output mass. Next up is a thing that I called shot temp. Now, this was actually the temperature from the refractometer, and I also captured the total dissolved solids from the refractometer, and then I calculated extraction, which is calculated as the total dissolved solids times the result mass divided by the input mass, and so this is basically whole percentage extraction. In this test, my average extraction was about 22.5%. Which is a little high. I was doing a little bit of over extraction. Again, I didn't start off planning that, but it's just something that I ended up with in the test. So I have learned some things about the way I actually do my espresso that it does allow me to tweak some things going forward to my taste. Now, you'll notice that there are no tasting notes or anything documented because, frankly, that is far too subjective for me. I don't want you to go off my opinions. You might have your own preference. So like I said, I'm extracting pretty heavy on my coffee. This is beyond what most people recommend, right? 22% is the top that most people recommend. They usually say 20 to 22%. I had some shots over 24% extracted during this test, so I'm doing it a little heavy. I plan on changing some things and seeing if I reduce extraction, if I prefer those shots. Because Lord knows, I'm open to considering that the way I'm doing things may not be the best. That's why I'm doing this test in the first place, because I want to know, is it worth the time of doing WDT, and what is it actually doing? How big is the influence on extraction? Now, in addition, like I said, I took logs of all the shots, and so you can see all this data. I actually have timestamps for each shot to the minute, so I could even go back and calculate how many hours old the coffee is out of the bag for each shot. Now, on the bags, I did document which bag it came out of. It's worth noting both of these bags are dated the same, so I'm guessing they came out of the same large batch. They are the same type of coffee, same roast, same date, just different bags. That shouldn't have too much influence, but I'll show you the statistics. All right, so let's look at some of the univariate statistics. Now, you can't draw super solid conclusions from this until you start controlling in a multivariate context for all the other factors that could affect the results. But it's always good to just kind of see what the overall kind of high-level results look like, and then you can kind of figure out whether all the controls really matter that much. So starting off looking at the average level of extraction, fairly consistent overall, but you do see that the method where I didn't do anything as far as WDT does show about a 1% less extraction, which is roughly like 5% less, whenever you actually think about how much more extraction were you getting by doing WDT. You can see it's about 5% more on average. Now, whether that holds up or whether that seems to be caused by other variables, we'll have to find out. So it does seem like both methods yielded pretty similar extraction as far as the different methods of doing WDT. And so there's not a huge difference there between doing WDT in the cup versus doing it in the portafilter right before you do a shot. But that's not all. I also can look at how consistent extraction is by looking at the standard deviation of extraction. And here again, you see that not doing anything led to fairly, quite a bit higher standard deviation. It's like twice as much variability in the outcome compared to doing WDT in the basket. Now, again, there's not a huge difference between doing WDT in the basket or doing it in the cup, but this isn't a test of significance yet, so I can't really conclude that. There is a different way to look at the variability of extraction, and here I've taken kind of the 95th percentile highest and 5th percentile kind of shots to see what the spread of outcomes were. And here, again, you see that the WDT methods really don't have much difference, but there is significantly higher variability, it looks like, whenever you don't do anything. So the conclusions, as far as much as you can get out of univariate statistics, are it does seem like WDT does give you higher extractions and more consistent extractions than doing nothing. However, it doesn't look like there's much difference between the two different methods of how you actually do your WDT when it comes to extraction. Now, again, we're going to test this more in a multivariate context in a moment, but that's just the univariate results. As far as flow rates and the mean time for the shot, really, really close together. It looks like, doing nothing actually ran a little slower of a shot, but this is really small. I mean, you're looking at a 1/10 of a second or less difference on average. Again, variability. The variability wasn't that much difference whenever you did WDT. It looks like it had a high spread. And so overall, there seemed to be the least variability in extraction time whenever you did WDT in a dosing cup. But overall, again, you don't want to draw too many conclusions from this table because it isn't controlled for a lot of other factors. Now, next up is a chart, and so there's a lot going on here, so let me kind of describe what this is. This is a visualization of the shot profiles for all these methods. And so I've used blue lines to represent shots that were done in a dosing cup. So the yellow lines are going to be the ones that had nothing done, and then the green lines are going to be the ones that had WDT done in the portafilter basket itself. And so here in the middle, these are the average flow curves across all the different shots. Now, there's not exactly 90 shots in this data because this is where I did lose some data points, but there's still like, I don't know, 78 different shots that are aggregated together. So each one of these curves is roughly 25-ish shots. And so what you see here is that the WDT shots ran a little faster through the middle of the curve. Now, before I get too far ahead of myself, in order to get all these lined up and everything kind of pretty, this isn't the full shot profile. Because I was using a little bit of pre-infusion, the beginning data is really, really noisy. And so I start these traces at 2 grams minimum. So down here, this is the shot as it starts from about 2 grams. And then I cut the data off once these things hit about 36 grams. Because again, at the end of a shot, you get dribbles and you get other stuff in the mass readings that just causes noise. So in order to keep everything kind of clean from the beginning and end kind of noise, these data points are recorded between 2 and 36 grams of output. And so what you end up seeing is that WDT method done in a basket does kind of have higher flow rates throughout the beginning or middle portion of the shot, and then it seems to slow down toward the end, whereas doing nothing kind of sat in the middle through the middle portion of the shot and seemed to run a little faster toward the end. And then you had the dosing cup, which seemed to run slowest through the middle and then kind of ended up in the middle toward the end here. It's just kind of interesting looking at the flow profiles. There's not a huge difference. Now, I do want to say, be careful looking at this. You see separation, but these are really actually pretty tight. You're only looking at a couple of grams different at, a couple seconds here. So I'm not saying that this is a statistically significant difference. And that's why I've got these other lines. So these upper lines, that's the 95th percentile curves, and then this is the bottom 5th percentile curves. And so you can kind of get an idea of the spread of outcomes. It's pretty wide, right? I mean, as far as you're looking at like a 2 standard deviation kind of a spread, none of these really looks that different. They're actually probably overlapping completely in a statistical sense throughout this. Now, the bottom 3 curves are the variability at each time point. So basically, you can think about at each point of extraction, how variable was extraction. So these are the standard deviations for each method at every point, right? And so what you see with this green curve is that WDT method actually had the highest variability of flow all throughout the shot. You see this bottom 5th is really, really low, and then the 95th percentile is pretty high. It had the highest spread of outcomes. And actually doing nothing seemed to have the most consistent kind of flow profiles. Now, you do see that variability kind of peaks in the middle, and there's some mechanical reasons for that. At the beginning of the shot, everything starts from the same place, and at the end, everything ends up the same place. So variability is very low at the beginning and end because I'm controlling those points. So naturally, you get more variability in the middle where a lot of different things can happen. Once again, I wouldn't take too much away from this. This is not a test of statistical significance. It's just looking at the data up to this point. Okay, so here we are. This is what I'm going to call my official results from this experiment. So this is a multivariate regression controlling for several different factors. Now, you won't see every single variable that I captured in here. And for those of you that are familiar with the way multivariate statistics work, you got to be careful with a lot of, it's called multicollinearity. You can get a bunch of your variables that they're so high in correlation that it can really screw up your results. And so I did drop a lot of things out that were causing some really funky things to happen in the statistical estimation. But I did check, and in general, these results seem pretty solid. I tried to end up with the kind of best, most robust kind of numbers based on the various specifications I could have used, while keeping the model pretty understandable, without doing a bunch of fancy transformations to the variables or anything like that. So this is a linear regression model, but I am using robust standard errors. And again, if that doesn't make any sense to you, don't worry about it. For those that do understand what that means, it didn't really actually make a difference. So even if I use regular standard errors, the results don't really change at all. Nothing of statistical significance is really affected. So with all those caveats out of the way, this is the regression on extraction. Does WDT matter? And the answer is yeah, and it looks fairly significant, right? Highly statistically significant and a fairly large result. Whenever you do WDT in my tests, I find extraction is quite a bit higher. However, there's a caveat, and that is these interaction terms. The interaction terms here say that whenever flow rates are higher, WDT has a smaller impact. And at high enough flow rates, it may not matter at all. And what that means is if you're pulling really, really fast shots, it really just may not make that much difference whether you do WDT or not, as far as extraction goes. And so as far as extraction, WDT seems to matter. It does seem to give you higher extraction, but there does seem to be an interaction with flow rates where the impact of WDT matters more whenever shots are slower rather than whenever shots are running really fast. And on flow rates themselves seem to matter at a pretty high level of significance. The faster your shots are, the more extraction you get. That's what I'm showing in my tests. Regardless of which method of distribution you use, whenever your flow rates are high, you tend to get higher extraction. This kind of backs up the idea behind pulling turbo shots, people running fast shots and getting really good extraction. I don't know exactly why, whether it's the puck swelling up and holding on to more stuff, whether the looser grind allows more things to flow through. I don't know. It could just be as much as faster moving water erodes more. I really don't know, but that's what the data says. All else equal, higher flow rates, higher extraction. Doing WDT, higher extraction. Now, the other thing I would say is I ran this model a couple of different ways. These two coefficients on WDT and doing WDT in a cup are really, really close together, and I've found that that's actually true statistically. There is no difference on extraction between doing WDT in the basket or doing it in a cup. So as far as extraction, it seems like the WDT impact is mostly that action of fluffing the coffee and maybe breaking up clumps. The distribution effect didn't really seem to matter in my tests, right? Doing it in the basket, making sure everything's well distributed, didn't impact extraction. The last thing I did note here is shot temp seemed to matter a little bit. Now, this was the temperature on the refractometer itself. And so when the coffee was hotter on the refractometer, that had a very small impact on the extraction readings. So again, there's a lot of controls here. I've controlled for the age of the coffee, what order the shot was, the temperature on the reading, whether or not I observed channeling, and the big event, right, whenever extractions seemed to change, ended up not mattering at all in my statistics, okay? So again, overall conclusion on extraction, yes, WDT tends to increase extraction. However, that increase is mitigated for high-flowing shots, and it doesn't seem to matter whether or not you do WDT in a cup or in the basket itself. Next, we can look at flow rates. How does WDT affect the flow of coffee? And here's where the results kind of get a little interesting. So the variable here is flow, which I basically use my data to calculate the average grams per second during each shot. So whenever you see these estimates, these are the impacts on grams per second flow rate. Now, WDT here says that whenever you do WDT, your flow rates are about 1/10 of a gram per second faster, and that is statistically significant. So WDT, the distribution effect, seems to matter when it comes to flow rates. Now, what's weird is some people I've seen have said that WDT will make things run slower. In my test, WDT made the shots run faster. And it did matter in that case doing it in the basket. If you did it in the cup, it might as well have not been done when it comes to flow rates. So WDT seems to matter for flow rates, and it does seem to matter because of that distributional impact. It's not the clump busting there. It does seem to be the better distribution somehow allows things to flow faster. Other things that seem to matter, my order and the temperature of everything seem to matter and cause things to flow a little bit better. Older coffee seemed to pull shots a little bit faster. And that event had a huge impact. It slowed flow rates way down. I mean, this is over 0.5 gram per second slower whenever that event took over. So that was definitely significant, and that's why I controlled for it in this regression. Now, the next thing to think about, and the last point I'm going to make, is WDT may have a compound effect, right? Putting it all together, the wisdom that people have about WDT, they probably are correct because this impact on flow rates is significant. And in the previous regression, flow rates increase extraction. So WDT increases extraction by itself, but it also causes shots to run faster, which can also increase extraction. And that may counterbalance the negative impact of extraction when WDT happens and you have higher flow rates. And so overall, if you put all this together in kind of a one statement, WDT does seem to matter, and both effects seem to matter, but in different ways. The clump busting or fluffing effect of WDT, that seems to impact extraction quite a bit. The distributional effect has more of an impact on flow rates than it does extraction directly. And it may be actually influencing extraction through multiple different avenues, as higher flow rates also cause higher extraction levels. Now, I will also point out that in results that I'm not going to show, I actually did some simultaneous equation modeling to see if that really mattered if I try to estimate all of this stuff concurrently in multiple different equation systems. And the results really weren't impacted in a significantly qualitative manner. Like, all the things I'm saying about the conclusions are the same. And since those models can be kind of hard to interpret, and people are probably much less familiar with systems of simultaneous equations and statistics, I really didn't figure it was worth breaking that out just to, do it, because it really didn't change anything. And so this is what I'm sticking with, right? Yeah, WDT does seem to matter. It does seem to increase extraction. It does seem to increase flow rates, and there is some limited evidence that it does seem to increase the consistency of extraction. And so overall, yeah, you probably should be doing WDT, and you probably should be doing it in the basket. However, doing it in the basket isn't the end-all be-all, because again, that mostly only affects the flow rates rather than extraction itself. Now, if anybody actually managed to watch this whole video, I will be very impressed, because I imagine this is probably one of the more boring things that anybody has ever done regarding coffee. But, if you got any feedback, feel free to ask any questions you have down below in the comments. As always, I appreciate your time. Thanks for watching.